Alright, so welcome back. Now we are going to go, after we did the moments on that last video and calculate the 775 at the reaction force at pin C in the Y direction, and we did 975 at the reaction force at A in the Y direction, we're going to go and find out all of the other forces that are acting upon pin A. So we're going to create a free body diagram at joint A. So the free body diagram is going to only include the lines and line segments that actually touch that point A, that bottom left corner of this truss itself. So the first line, segment, or ray that we have, or vector, that touches that pin A is the reaction force at pin A in the Y, and we solve that to be 975 when we did the moments. Then we have this member AB. So we have the force of member AB is going and interacting with that pin A, or that point A. So we pull it away from the pin because the directions, or how we're going to do it, is always assume tension or pulling away. Then another action we have there is we've got the force of member AD. So that AD is that angular one for us. Whenever we have an angular vector, we break it up into its two components. We have the force of ADX, and then we'll have the force of ADY. So ADX and ADY are the two composite vectors that then help build that larger force of AD. So force of A, reaction force at pin A and X, we missed it in the moments, but that's equal to 0 because when we look at the big picture before getting anything smaller, there are no other forces in the X direction, just that one itself. So what we're going to do is we're going to calculate force, sum of all the forces in the Y direction equals 0. Well, in this case, we only have two. We have the reaction force at pin A in the Y direction, and we have the force of AD in the Y direction. Those two need to, sum of them equals 0. Since we already solved, reaction force A in the Y direction needs to be 975 up. The force ADY has to be 975 down. So now what we've got is we're starting to work at and try to form and create and use. So we've gone through, and now we've got that right triangle. That red section right there, the force of AD creates a right triangle. We need to go and calculate the angle. Yes, in the picture it says that 45, but where did that 45 come from? Well, it came from the right triangle trig. We've got 3 by 3. So this here is 3, that there is 3. So you got the opposite and the adjacent. So the inverse tan of 3 over 3 gives us that 45-degree angle that we're using with. So now we're going to go and solve this red triangle that's right here. We have got the sine of 45, the angle that's right here, equals the opposite, 975, over the hypotenuse. So that's how we're going to find the force of AD. Then how are we going to find the force of ADX? Well, tangent, because ADX is adjacent to this angle. Then we know our opposite, so we've got opposite over adjacent gives us tangent. So the sine of 45 equals 975 over the hypotenuse, so the force of AD. So that gives us the force of member AD is 131,378. I guess we can round that up to 9 if we need to. And then we've got the force of AD in the X direction. That other leg of that triangle is 975 divided by tangent 45. Gives us a nice 975. If you remember from your geometry, 45, 45, the two sides be equal to each other. The proof is in the pudding right there when we solve that. So now we're looking at sum of all the forces in the X direction needs to equal 0. So we have one force in the X direction, being the force of AD is in the X. We saw that the force of ADY is going down, so therefore it's applying compression because it's got to get to that point A. So force of ADX needs to be going to the left at 975. So therefore the force of ABX needs to be pulling away and be in tension. So force of AD is in compression because the force of ADY was going down, so it's pointing towards the joint A. And then, since we have the 975 going left from our trig that we solved for the force of ADX, that means then the force of ABX at 975 has got to be in tension, pulling away. So now that we've got this solve for, we can go to the other side of the triangle next and start solving for these remaining members that are intersecting at joint C.